Welcome to the office. I want to take a quick look at a couple of definitions and a theorem here, just to give us what we need in order to take a look at a couple of examples. So we have two subgroups of particular interest. These are normal subgroups. One of them is the center of a group. And actually, I suppose, you know what, it doesn't specify that the center is a normal subgroup. So maybe we don't actually have that. I hadn't thought about that too much. I thought they were both normal, so I apologize. Anyway, two subgroups of interest. The first being the center. The center of a group is simply whatever elements commute with everything. Cool. On the other hand, we have what's called the commutator subgroup. Now, if we had that AB was equal to BA for all of our elements in the group, then we could multiply both sides by the inverse, and we would get A times B, right? If we actually had commutativity, then I could take the inverse, and the inverse of BA wouldn't be, or I suppose it is, the inverse of BA is A inverse B inverse. And we would get 1 or E, whatever the case may be, right? So if I had commutativity, then this is what I could do. So if I kind of just ignore this and just look at this, all of the elements that take on exactly this form, right? If it were commutative, that would just be E, and that's it, right? The identity. But if we go ahead and modulo by this, so that way this is the identity, then we create what is an abelian group. Right? Because that's what we do when we quotient. When we quotient by something, we're turning all of those things into the identity. So if I make this equal to the identity, then what I will have is something that is abelian. So when I find the factor group where I'm considering the normal subgroup, the commutator subgroup, then what results is abelian. All right, so just to be clear, a commutator itself is an element that takes on this form. If we consider all of the elements of that form, it is the commutator subgroup. We haven't proven that it is a subgroup, but well, it's the subgroup generated by all such elements. So if we take those as the generators, then we consider the subgroup that is generated by them. Okay. Now, I might consider the commutator subgroup is a normal subgroup. Fantastic. That means we can find the factor group or the quotient group. Now, interesting bit. If n is a normal subgroup, and so if n is a normal subgroup, G mod n is abelian if and only if it contains the commutator subgroup. Cool. That's interesting. Very wonderful news. We're going to use that idea a little bit. We won't, I suppose, use it too much. What we're actually going to do is we're going to point to the book that already did a little bit of work for us, which cites this theorem, and we're going to use its results. So join me here in the office for a couple of examples in just a moment.